Hello everyone, this is the tutorial for Chapter 10, Confidence Intervals Based on a Single Sample. A confidence interval is a range of values constructed so that with a specified degree of confidence, the value of the population parameter lies in the interval. The confidence coefficient is the probability that the confidence interval encloses the population parameter in repeated samplings. So the confidence coefficient can take values between 0 and 1. Common confidence coefficients are 0.9, 0.95, 0.99, and the confidence level is just the confidence coefficient expressed as a percentage. Below is an illustration of what a confidence coefficient is. So each one of the horizontal lines is a confidence interval, a 95% confidence interval, and we have 20 repeated intervals here, and each interval is based off of a separate sample. And we have the mean here, which is the vertical line, and we can see that 19 out of 20 of the 95% confidence intervals capture the true value of mu, and one of them doesn't, and it's highlighted in red. And it also shows that not only is it possible for the value of mu to not be captured in an interval, it's also possible that the value of mu is going to be towards the edge of the interval as opposed to always being in the center. So in repeated confidence intervals, the proportion of all 95% confidence intervals that capture the true value of mu is 0.95. Now below is an example of how to calculate the confidence interval for mu. In April 2013, the second set of biomonitoring data from the Canadian Health Measures Survey was released. This report contained information on 91 chemicals and was designed to track levels over time in order to assess certain regulations and health risk management actions. 100% of Canadians tested in this survey, aged 3 to 79, had lead in their blood. However, almost all had blood lead levels lower than the current intervention level. A random sample of 50 Canadians was obtained, and the blood lead level in each was recorded, and it was recorded in micrograms per deciliter, and the data is given below. So we have a data set of 50, a sample size of 50, and each value is the blood lead level recorded in micrograms per deciliter. And we would like to find a 98% confidence interval for the true mean blood lead level in Canadians. So there's several ways to calculate a confidence interval given the kind of information that you know. So the first way that I'm going to go over is calculating the confidence interval for mu. And again, mu is the true mean blood lead level in Canadians when sigma, which is the population standard deviation, is known. So let's suppose sigma equals 0.3 micrograms per deciliter. The first thing you want to do is calculate the sample mean and the critical value, which in this case comes from the normal distribution and denoted by Z. So the sample mean is going to be calculated the regular way, and it's 1.254. The critical value with alpha equal to 0.02, because we're calculating the 98% confidence interval, is going to be 2.3263, and this value you can either use R or another piece of software or even a table to find it. And the interval is going to be given by this equation. So we know sigma, it's known. We know n, it's 50. We know the critical value and the sample mean because we just calculated them. And when we plug them into the equation, we get an interval of the following. And what it means is that we can be 95% confident that the true mean blood lead level in Canadians is between 1.15 micrograms per deciliter and 1.35 micrograms per deciliter. Now, part two of this question is how do we calculate a necessary sample size? To go into more detail on this, the error on the estimation of the mean, and the estimation of the mean is given by the sample mean. It decreases as the sample size increases. we would like to bound the error of the sample mean to 0.1 micrograms per deciliter. The question is how large a sample size is necessary to achieve this accuracy. So the bound M is simply the thing that you add and subtract to the sample mean to calculate the confidence interval. So it's this thing here. And I've given it again below. So M is equal to the following. And if you rearrange it for N, which is the sample mean, or N, which is the sample size, we can calculate the sample size. So M is 0.1 micrograms per deciliter. Sigma and the critical value are known, so when you plug these in, you get N is going to be equal to 48 point something, and then you round it up, you get 49. And this is the sample size that's necessary to bound the error to 0.1 micrograms per deciliter. And this makes sense because we have a sample size of 50 in the question, and the bound or the margin was calculated to be about 0.1. Now, part 2 shows you how to calculate the confidence interval for mu, which is again the true mean blood lead levels in Canadians when sigma is unknown and the sample size is large. So a large sample size would be anything over 30. We're going to be using the same question. So the first step is to calculate the sample mean, the critical value, and the sample standard deviation. And again, the critical value comes from the normal distribution. So we calculate the sample mean the regular way. We get the same answer, 1.254. The critical value is the same, 2.3263. And now we calculate the sample standard deviation. This is the additional step to what we did above. And it's calculated to be 0.272, right? Which is pretty close to the known value that we used in the prior question, which was 0.3. And to calculate the interval, the equation is almost the same. The only difference is instead of sigma, which was the population standard deviation, we use S, which is a good estimation for the population standard deviation. And again, S is the sample standard deviation. And we get an interval of the following here. And we can say that we are 98% confident that the true mean blood lead level in Canadians is between 1.16 nanograms per deciliter and 1.34 nanograms per deciliter. Now the last part is calculating the confidence interval for mu when sigma is unknown and we have a small sample size. And a small sample size would be anything under 30. So we're not going to be using the same data from above because in the above questions we had a sample size of 50. So let's suppose that the new sample size is of size 15 and it has the following summary statistics. So X bar, the sample mean is 1.2, the sample standard deviation is 0.25, and the sample size is 15. So again, the first step is we want to calculate the sample mean, the critical value, and the sample standard deviation. And so the sample mean and the sample standard deviation are given as 1.2 and 0.25 respectively, and the critical value, because we have a small sample size, we have to get that from the t-distribution. So alpha is 0.02 and n is 15, so the critical value is found to be 2.62, and you can use R or a table to find this. And the interval is given in a similar way to the prior question, except now the critical value is replaced with the critical value from the t-distribution. So we get a confidence interval of the following, and this tells you that we are 98% confident that the true mean blood lead level in Canadians is between 1.03 nanograms per deciliter and 1.37 nanograms per deciliter.